Are you able to hear me?
Yes.
Yes.
Okay, fine. Good morning. So today let's start our discussion on partitioning and clustering in BigQuery. Okay, so let me quickly share my screen. Hope you're able to see my screen.
Yes.
Yes.
Okay. Fine. So yesterday we have discussed what is partitioning in BigQuery and why we need partitioning of data, right? So and then we have seen some advantages of partitioning and some limitations, right? So in BigQuery we cannot do partitioning on the string type columns. So we have date, timestamp, and integer column based partitioning that is supported in BigQuery. Just give me a second. Okay. So then we'll see examples of partitioning. No need to worry. So let's understand the concept of partitioning. Okay. So partitioning means when we have very huge data and when we are querying that the data using where clause or where filters. So when we do the partitioning of a table, and if we use that partitioning columns in the where clause, so the table scans will be reduced. Okay, the table scans will be reduced. So partitioning results in avoiding full table scan. So thereby, we know BigQuery reads are costly. So when we read the data, if the scan is less, the cost will be less. Okay, so that is the advantage of partitioning, and it is also one of the performance optimization or query optimization technique. Okay, now let's move on to the clustering, right? So basically the clustering is also kind of a storing or ordering the column or organizing the data in the backend. Okay, so meaning, so BigQuery will store the data internally in the blocks. Okay, BigQuery will store the data internally in the storage blocks. So that storage blocks will be ordered and sorted based on the column value. Meaning, let us take an example. I have clustered by ID column. Okay, now what BigQuery will do is BigQuery will sort these ID column values, and then it will store the values in a blocks. So because it is sorted data, so BigQuery, what it will do, when we query on top of this column, that index, so the pointer will go fast, and because of that reason the query performance will be increased. So when we do cluster by on a specific column, so what will happen, it will store the data in a sorted fashion. So that sorted fashion storing will increase the query performance because the pointer will move faster on the sorted data. Okay, so that is the biggest advantage of your clustering of BigQuery table. Okay, so usually in real-time projects, we do partitioning and clustering both. On a table to increase the query performance. So what we will do, so we will initially do the partitioning on few columns, and then we will do the clustering inside the partitioning. That is the thing that we do in real-time projects. Okay, let us say I partition by date, I cluster by ID column. So the column to do the clustering, right? So the column selection to do the clustering is unique column. Be very, very clear. So the column should be pretty much unique to do the clustering, so that the clustering works better. For partitioning, it should be a duplicated column. So the data elements inside the column should be duplicated for partitioning. Okay, and then the clustering will be the unique column. So you need to select unique column for your clustering. That is the difference. And so here, if you see the queries that filters and aggregates by on the clustered columns only scan the relevant blocks, right? So meaning, so when it sorts the data, so for example, it sorted the data and then it has stored it in a block, right? So it will scan only that particular storage block for reading the data. Because it is sorted, the pointer will as and when it catches that block, immediately it will stop there. So that is how actually the query performance will be increased. Now this is let us take an example. See here, you okay. So here, if you see, simply, I mean, just to show an example of how actually it will sort and store. So if you see uh, the non-clustered and then clustered, right? So it will store in this fashion internally. So here, if you see the country. In the partitioning case, what it will do, guys, it will create a separate partition for that specific data. But in cluster, it will sort the data and then it will store all the same data in a single block. So that is why, if you see the cluster by country, so all the US countries will be sorted and then stored in a single block. Okay, and then again the JP country, and then UK, and then KE. So if you see the clustered by country, so it sorted the data and stores in a different storage blocks. So that is the reason why when we partition by order date here, let us take an example, and then cluster by country. So what will happen? So it will go inside this particular partition, and then it will go to that respective block only. It won't scan all the blocks in that partition also. So that is where actually you can increase the query performance. So maybe I'm contradicting my statement. There is no such rule that you should not use cluster by on duplicate columns. Okay, but the recommended or preferred way of doing cluster by inside the partitioning is unique column. Okay, on the unique column. Be very clear. Just to give you a good example, I have explaining this. Okay, so you it is not mandate that every time you need to create cluster by on the unique column. You also can do cluster by on the duplicate column, but the recommended way is partition the duplicate column and then cluster the unique column, so that it will give the most performance. Okay, so any questions or queries, guys? Are you clear, or any confusions here?
Yeah, clear.
Okay, fine. So let's move on to the practical examples of this partition by and cluster by. How to create a partitioned table, right? How to create cluster keys in the BigQuery table. So we will see that practical examples, and we will also see a concept called stored procedures in BigQuery today. Okay, so these are the three practical things that we will cover today. Okay, so let's quickly jump in and open up our BigQuery. So here we have the BigQuery. Okay, and here we have employee data. Select star from employee, right? So let's see what is there in it. Okay, I have 1,000 records, and then ID, first name, last name, email, gender, IP address, and then created date, right? So let me see what are the distinct created dates. Okay. So out of 1,000 records, I have 340 distinct created dates. Okay, fine. So I'm going to partition my data on created date. Okay. So here I'm just trying to create a table. Create table, or else I will take the existing SQL I have. So here, if you see, I'm just trying to create a table and trying to partition on created date. Okay. Okay. So here, how to create a partitioned table, right? So we know we will do the partitioning on a specific column or a multiple columns in the table. So here, if you see, I'm creating a table called underscore employee data underscore target. Okay. So this is what the table that we are creating, and these are the column names that I have. Okay. And I have ID, first name, last name, email, gender, IP address, and created date. Okay. So now what I'm trying to do, at the end you need to pass a statement called partition by the date column. Partition by the date column. So when you do this, so what will happen? So it will create a table. Okay. So it will create a table uh, which is actually the partitioned table. Okay. So here, if you see, I have this employees data. Okay. So let's quickly understand where is this. Okay. Yeah. Here, if you see, it is actually the partition table. This is a partition table. The When you click on the table itself, it is giving you the information, right? So let me quickly reopen or reload the BigQuery. Cloud storage. Leave. Okay. So our DB is EMP So this is our data set. Inside the data set, if you see, I have employees data target as a partition table. Okay. So you see the difference, right? No, normal table and then partition table. Okay. So now let's try to load the data into this table, right? So let's try to load the data into this table. So I already have data in stage EMP data. See here. So I already have loaded the data into this table, which is not partitioned, and it's a stage table or else intermediate table, you can say. Okay. So you can simply load data from that table to this table by using a simple insert statement. Okay. So how we will load the data? So here, if you see, we'll simply see how we can actually load data by using the insert statement, right? So by using the insert statement, you can simply load the data into the table. Okay. So here, if you see, empdb.employees data underscore target, so is our table. And then what I'm doing, I'm taking data from the stage EMP data, insert into this table, select star from another table. So this is the query that we use when we load the data from a stage table to the target table, or intermediate table to the target table. So Be very very clear, this query will be using in real time very often, guys, because we'll be loading data from table to table, or we'll be loading data from stage to target, right? So this is the query that we use. The limitation for this query is that the column names should be same, or else you need to select the proper columns, whatever are available in the target, otherwise it will fail. Okay, so now my target table is a partition table, and I have a non-partitioned stage table. Now what I'm trying to do, I'm trying to load the data from non-partitioned table to the partitioned table. Okay, so this is the activity that I'm performing. So when you do this, so your query will get triggered, and then it will start consuming your slots, right? So this statement added 1,000 rows. So you can always go here and check the execution graph, right? So now I have data in my partition table. Okay, and when you click on this table details, you will clearly see the partitioned details, right? So what is the table type? It's a partition table, and partition by day, and partition on field created date, right? So here you can clearly see how actually the table is partitioned, right? So you can query the data. You can start querying the data. So let's first query. Because it's a very small data, you don't see much difference. So first we will query the non-partition table, then we will query the partition table. Okay, so here I'm just taking one of the created date. So I'm trying to query. Okay, okay, so this is very small data. I don't think you'll see the difference. So when you have very huge data, so definitely this partitioning will help you. Okay, so that is actually, see, so the partitioned table took more time. So that this is not correct. Okay, usually this query will take um, this query will take less time. The reason why it executed fast, I'll tell you the reason. So here the select star from emp dot stage uh, empdb.stage emp data. This table we already queried for the insert statement. Okay, so what BigQuery will do? BigQuery have that self intelligence. If we execute the same query multiple times, it caches the data. Okay, so that is the reason the select star from your empdb to stage emp data came so fast, because we already executed this query and the data is in the cache already. Okay, so that is the reason it got executed in 30 milliseconds. Okay, so uh, for a very small data set, you don't observe much difference. Okay, you'll see the difference actually when we have very huge data. Okay, we'll play with the examples with 1 GB or 2 GB files, so that we'll try to understand the power of partitioning. Okay, we'll see those examples in our later sessions, but for now, try to understand how we are creating a partitioned table and how we are loading the data into the partition table. Okay, so any questions here, guys? Any questions or queries?
No.
Any questions? Are we good? Are we able to understand? Anusha, Prakati,
No, Venki.
No, Venkat.
any questions? Okay, Ranganath, are you able to understand?
Yeah, yes, Venki.
Thank you. So that's what the partitioning. So how we will create the partition table, and then how we will create how we will load the data into the partitioning table, right? So the next practical example that we're going to see is the clustering, right? So how we will do the clustering, right? So clustering is something that we do inside the partitioning always, but you can also do the clustering alone. Okay, so I'll try to create the clustering inside the partitioning. Okay, so here, if you see, I'll just simply copy paste my example. So here I will say employee data underscore C, okay, PC. So I'll say partitioned and clustered. So and then what I will do, I will simply say partition by create date, and then cluster by ID. Okay, so see here, you use cluster by keyword to cluster your columns. Okay, so what it will do, it will internally sort your values that are there in the ID column, and then it will store. So all the same values will be stored in the single block. Okay, so that is the functionality of your clustering. Okay, so now let's see. Okay, so now your table got created, which is actually partitioned and then clustered. Okay, so now let us execute the same query because we have non-partitioned stage table. Okay, and then we will try to run this. So not found. Okay, so this is not target, this is only PC. Okay, so now we are creating a table with partitioning and clustering, and we are loading the data into that table. Okay. Okay, so this table has also loaded. So let's quickly query this table. So you need to use your partitioning keys and clustering keys in your where clause. Otherwise, you won't be able to get the advantage of your partitioning, right? So where created date equals to created date equals to, let us say 2024-02-15, and id in. Okay, id in. So first we will see what are all the things that are there in this. Then we will apply the cluster by. Okay, so this is what my query written, and the row IDs are 1 to 2. So I will say where ID between 1 and 2. Oh, sorry. Okay, so because it is always exclusive, right? So you can say ID greater than or equals to 1 and ID less than or equals to 2. So when you do this, what will happen? So it will go and query only that filter. Why it is not giving anything?
It mentioned in and I think that's why.
Okay. Okay. So this is how you can make use of your partitioning and clustering both. Okay. So but I mean, the thing you need to understand is if you're not using your partitioned or clustered columns in your where clause, okay, so you won't get any advantage of your partitioning or clustering. Though you partitioned your table, though you clustered your table internally, but if you're not utilizing those columns inside your where clause, you won't get that functionality or advantage. Okay, so this is one thing that you need to keep in mind. And cluster by you can implement on multiple columns, partition by you can implement on multiple columns. There is no rule that you need to do partition by cluster by on single column. Okay, depending on the data, depending on the front end query patterns, right? So always your downstream query patterns is very important. So depending on the downstream query patterns and depending on the data set that you have, you need to apply these partitioning and clustering keys. Okay, so in real time projects you will be getting requests like in a production table because of performance lag. People may ask you to add partitioning, people may ask you to add clustering. So in that time, what you will do, you will back up the existing table, and then you will create a new table with partitioning and clustering keys, and then you will load it from the backup table. So that's how you do activities in real-time production environments, right? So these are some things that you need to keep in mind. Okay, partitioning and clustering. So these two are the optimization or query performance techniques in BigQuery. And if you are not using these partitioning and clustering columns in the where clause, you don't get the advantage of these functionalities. And there is no limitation for number of columns in partitioning or bucketing. You can do partitioning and bucketing in multiple columns. Okay, sorry, partitioning and clustering. Bucketing is the Hive concept. Okay, so partitioning and clustering you can do on multiple columns. Okay, but in BigQuery there is a limitation on partitioning with respect to the type of column. So you can do partitioning on the date column, timestamp column, and integer column. So these are the three types of columns you can do the partitioning, but you cannot do the partitioning on the string type column in or any kind of complex type columns like array column, JSON column. So you cannot do that using these columns. Okay, so this is what this is what about partitioning and bucketing. Anybody have any concerns or queries, guys? Please raise if you have any questions.
Yeah, hello.
Yeah,
On clustered, only on based on integers or any string type we can.
you can do on string type also.
Okay. Only condition is partitioning only on integers.
Sorry.
In clustering, we can't uh, query the on the string columns, right?
No. Clustering you can apply on any type of a
Any
column.
type of column. In
Mm.
partitioning, only on integers,
Yes, only on integers.
integers and date.
Yes, correct.
Okay.
Okay. So,
Thank you.
yeah.
While using this partition table and normal table,
Mm.
uh, before partition table got more time because of that cache. No? Can't we clear that cache for a better performance?
Yes, we can clear that cache, but I don't know if this free version will support that. In enterprise versions, we'll be having that option here, somewhere here in the actions. Okay. I don't see that option here, Ranganath. So I think it will be. It should go automatically. BigQuery to review, Robin, editor, short details. Okay, usually we will get this option here in the actions, so clear query or clear cache or something like that. So I think it is not coming. Okay, so okay, 1 second. Oh my God, what happened to me? Okay, so okay, so just to bypass that part, right? So what we can do is, so we can actually go and try to create another table. Okay, so create table empdb dot testing underscore non underscore partitioned. Okay, so as select star from this. Okay, so sorry. Yeah, so this is I don't know whether this will support. Okay. Okay, so in here, what I'm trying to do, I'm trying to load the stage emp data to another non-partition table. Okay, so we'll try to apply the query on this. Okay, we'll take the partition table and then just this employee data target, right? So details target. Okay. Okay, so here if you see, I am trying to run this query, which is actually the non-partitioned one. Okay. So I think let's see the execution details. Took around 79 milliseconds, right? So we'll try to execute this. Anyway, this query is also being executed, right? So let's run this query. You got it, Rangna?
Yeah.
Yeah. So this is, I mean, there will be default uncache time for BigQuery. It is 5 minutes or 10 minutes. So after that, the query will be automatically, the data will be automatically uncached. So that is something that, okay. So finally, we were able to understand the partition table is giving lesser execution time compared to the non-partition table. Okay. So that is okay. So any other queries? Any other questions or queries, guys? Okay,
No.
okay, fine. So we have seen how to create the partitioning, how to create the clustering, and we have seen how to load the data to a clustered table or a partition table, right? So fine. So now, so what we can do is, so we'll look at a concept called stored procedures. Okay, we'll look at a concept called stored procedures, right? So in real time projects, so what is the advantage of stored procedures? So let us quickly first understand that. Okay, then we will jump into the stored concepts, right? So let me explain you. Okay, so let us take an example. You want to write a query. Okay, so what you will do, you will write a query, dot SQL, or in SQL you will have create statement, and then a select statement, and then insert statement. So there are multiple kind of queries that you need to execute at once, and those queries should be executed one after another. Okay, and you also need to do some kind of a processing in between, yeah, based on the conditions you need to execute the query, or based on the loops you need to execute the query, right? So there is a procedure based language that will be provided by the SQL. So you can write your queries in a sequence like a programming language. Okay, so that is what we call it as a stored procedures. Okay, stored procedure is a script of SQL statements. Okay, is a script of SQL statements. In stored procedures, you can actually use all your programming concepts. Like in Python, how you will do program, right? You declare variables, you declare it, the variable types, you cast the variable types, and you apply if conditions, and then you apply variable declarations, right? You assign values to the variables, all the programming concepts, right? So similarly, you can also write it in SQL. Okay, that is what we call it as a stored procedure. These stored procedures are not restricted to any of the database, guys. You can write these stored procedures in any of the database. Even in SQL Server also you can write the stored procedures. Even BigQuery supports stored procedures, right? So any database you can write a stored procedures. If you put your all SQL statements depending on their sequence or depending on the conditions, right? So what you need to do is you need to create a stored procedure and put your queries inside that stored procedure, call the stored procedure, so that all your SQL statements that are there in that stored procedure will be executed one after another. Okay, and that will achieve the required purpose. Okay, let us take an example. Let us take a use case, guys. Okay, so you have a requirement, right? So you have a requirement. I mean, you loaded the file into the BigQuery, sorry, into the GCS. Okay, into the GCS you loaded the file. Now the requirement is you need to load that file into BigQuery table first. Okay, one stage table. Once you loaded the file to stage table, then what you need to do, you need to create another table, and then that table is a truncate and reload every time. Okay, so you need to create another table and load the data load the data from the stage table. So for this purpose, you need to use multiple SQL statements. Okay, and one should be executed after the previous statement got successfully executed. So if you have such kind of scenarios, and also if you have such few variables, and based on the variables you want to apply the condition, if this variable is this, and then execute this query, if this variable is this, execute this query. So if you want to route your SQL statements based on the condition flow, right? So in that scenarios, you will go for stored procedures. Okay, so how we will create these stored procedures in BigQuery especially, right? So you can use create or replace stored procedures. This is same. This statement is same in all the databases. You can try in your SQL server also. The data types and declarations may differ, but the concept is same, guys. Okay, so let us quickly see a simple stored procedure. Okay, let us quickly see a simple stored procedure. So here, if you see, am I am creating a table. Okay, I am creating a table. Sorry, I'm actually trying to create a stored procedure. Okay, so I'm just clicking on plus here and then pasting everything here. Okay, see here. Observe the syntax, guys. So create or replace procedure. Okay, create or replace procedure, right? So where I'm trying to create my procedure, I'm trying to create it in the EMPDB. That is my data set. Okay, under this data set, I'm trying to create a stored procedure. Okay, so create or replace procedure empdb dot create and load partition table. Okay, this is my stored procedure name of the stored procedure. Once I have given this statement, then I need to start my stored procedure with begin. Okay, begin is a keyword that we need to use to start your stored procedure. Okay, begin is the keyword we use to start your stored procedure. Okay, now once we have done begin, see what we are trying to do. We are trying to create variables in the stored procedure. Okay, how we create variables in the stored procedure? We are using declare keyword. Declare variable name and its type. We'll assign the value later, but we need to declare the variables first in the stored procedure. Be very, very clear. Okay, you can assign the values later. Okay, but you need to declare the variables. All the variables that you need in your stored procedure, you need to declare them in the beginning itself. Okay, so that you can assign the values later. Now you declared variables called create table statement, load data statement, and those two statements are string types. Okay, now you are assigning the value. So how you will assign the value to a variable? You will use set command. Okay, so to create the variable, you will use declare command. To assign the value, you will use set command. Okay, so now you are using set command. Now set the variable name equals to, and you are assigning a string of create table statement here. See here, right? So here you're assigning the value, string value, to the create table statement variable. Okay, now this string value consists of your actual SQL statement. Okay, now here you're calling your SQL statement. Execute immediate is a function. Execute immediate is a function or a command in BigQuery. By using this, you can actually execute your SQL statement. Okay, so here what I'm doing, I already assigned this to a string variable, so that I'm calling that string variable directly to my execute immediate statement. Okay, so now what will happen? You will try to it will try to create the table here at this step. Okay, now table got created. Then again, what I'm trying to do, I'm trying to set another variable called load data statement. And in this variable, what I'm trying to do, I'm trying to put my insert statement. Okay, and then I'm trying to use execute immediate again, and then calling the variable. So this is a basic stored procedure. Okay, this is a basic stored procedure. Okay, so I think everybody got the sense of what is a stored procedure and how we will write the stored procedure, right? So here, if you see, every time when we write stored procedure, you need to remember we need to begin and then end the procedure. Okay, in between you write your SQL statement, sequence of or series of SQL statements. Okay, so in real time you will see, a very big stored procedures in real time projects. You will see very big stored procedures because each and every procedure will be having a functionality. Okay, so why we don't use multiple SQL statements itself, right? So the deployment will be very complex. If you, for example, you have 100 different queries needs to be executed, right, in your project, one after another, one after another, one after another, right? And then depending on the conditions also, you need to execute, and some processing logic is there, right? So a lot of joins are there. So what you will do, you cannot maintain multiple query statements and then trigger, right? So what they will do is they will write a single script or single procedure in SQL, and then the deployment of that script will become easy, right? Instead of maintaining triggering multiple different queries or multiple different statements manually one after another, what we do, we create a script in SQL and we'll submit that script to your database engine, right? So in that scenario, the deployment will be very easy. Okay, the deployment will be very easy. So how you will deploy the stored procedure? You can trigger the stored procedure from anywhere, right? So for example, in your pipeline, you have a cloud function, or you have some other service, data proc. From the data proc also you can trigger the stored procedure. From the cloud function, you can trigger the stored procedure in BigQuery. So you can call single script, and that script will take care of the entire processing or loading all these functionalities or merge. So majority of the times we use this stored procedures in load patterns. Okay, so meaning, let us take an example. You are loading the data to a stage table, okay, the temporary table, and then from the stage table the data is going to the target table, or else from the stage table the data is going to the multiple target tables. Okay, so now what you need to do, in your data proc, you applied the processing logic and you return the data to stage table. Okay, and once the data has been written to the stage table, and you will call a stored procedure, that stored procedure will execute the logic of loading it into multiple different tables, right? So this is how we'll plan in real time projects, and then we'll make use of this stored procs, right? So any questions or concerns with respect to stored procedures, guys? Any questions? Are we able to understand, I mean, where actually we use stored procedures, what is the purpose of stored procedures, and how to create the stored procedures in BigQuery? Are we good?
Yeah, clear.
Okay, okay, fine. So that's all I have for today, guys. Tomorrow we will see the BigQuery specific functions, like explode or unnest, right? So along with the SQL, what extra features BigQuery have, right? You can process JSON data, you can process XML data, right? So using BigQuery, you can process XML data, you can process JSON data, you can process array type data, list type data. So how we will do these processings, and what are the BigQuery functions that we can utilize to achieve these functionalities, right? So we will discuss the BigQuery specific functions tomorrow. Okay, and then later on we will proceed for the further concepts in BigQuery. Okay, so this week we will focus on BigQuery. Okay, so by this week we'll try to complete the BigQuery part, and then next week we will jump into the data proc. Okay, so hope everybody started practicing your SQL in BigQuery. Okay, do your aggregation functions, min, max, average, group by, right? So all these SQL functions I want you to try in BigQuery. Take the sample data, take very huge data sets. Okay, download CSV files from the internet. Okay, so you just search in the Google, get good data files, load them using NiFi to BigQuery, query in the apply SQL queries in the BigQuery, take multiple use cases. You know all the advanced analytical functions we have discussed in the SQL sessions, right? So row number, rank, dense rank, all these functions we know. So try to apply those advanced aggregation functions, lead and lag functions. So you just practice, right? So you need to keep on practicing. Okay, my responsibility is taking you towards the new concepts. That's it. So that doesn't mean that you should leave your old concepts. Okay, you should keep on practice, otherwise you will forget. Okay, it looks like it is very easy, but in reality it is not, guys. Okay, if you're not practicing you won't be able to write a simple select statement also. Be very very clear. Okay, in interviews, if you are not practicing, you may feel that, okay, I know everything. Okay, you may feel that, okay, so these are very simple, I can write any query. But if you're not practicing, you will definitely I'll challenge you, you will definitely won't be able to write any simple query also. Okay, so that is the reason I am asking you to practice. Okay, so build NiFi pipelines, take different use cases. Okay, and keep on working on NiFi pipelines, and then keep on writing your Python codes, keep on practicing your SQL statements. Okay, so then only you'll be able to crack the interviews. Okay, so that's all I have for today, guys. Thank you so much for joining once again tomorrow. Yeah.
Thank you.
Yeah, thanks.